So this is something you might have done, maybe not in Algebra 1, but Algebra 2, if you had something to the fourth. Algebra 1, you learned about the difference of two squares. Then you factored a lot. Our first three spirals, speaking of that, we have a spiral due Friday if you haven't done that yet. There was a lot of factoring and a lot of solving. The reason for that is because factoring just keeps on coming back up. So, trig expressions, we're factoring. So x to the fourth and y to the fourth, those are both perfect squares. So when we have the difference of two squares, we take the square root of the first, split it up, the square root of the last, split it up, one side's plus and one side's minus. Doesn't matter if you do plus and minus or then minus and then plus. They're exactly the same. Now, have we factored it? Yes. We have not factored it completely. X squared plus y squared. A lot of times you think there's something we can do, but there's nothing we can do with x squared plus y squared. X plus y times x plus y gives us x squared plus 2xy plus y squared. X minus y gives us x squared minus 2xy plus y squared. So there is nothing you can do with the x squared plus y squared. But the x squared minus y squared is, again, the difference of two squares. So we have to bring down this, and then just like we split up, we took the square root of x to the fourth, now we take the square root of x squared, which is x times x, square root of y squared, y times y, one's plus and one's minus. And so now we have factored that problem. Now, on this unit, we're not doing anything with letters, everything's words, but I'm just showing you how it's the same. All of a sudden we put words in there and all your math skills have gone out the window. It is no different. It's just a word. Think of that word as a thing that stays together. You need to circle the signs, box the cosines, put a triangle around the tangents, whatever it is, so that you know those things are the same. All right, so now all I did was replace the x with tangent and the y with cotangent. So now we're going to factor we're going to follow the exact same steps. It's just with words. So those are still perfect squares. Tangent squared x. Some of you are writing that wrong. Be sure the squared goes on the tangent, not the x, because that is very different, and in this case, very wrong, if you put the squared in the wrong place. And then the square root of cotangent to the fourth is cotangent squared x, cotangent squared x. One's plus, one's minus. That's factoring the difference of two squares. And just like the one with letters, we still have the difference of two squares. Now, a couple days ago and earlier in the year I said, remember, add and subtract is different than multiply. While yes, that is a very easy statement to determine the difference, all of a sudden we put in words. If I told you 1/3 times 3 over 1, that's equal to 1. But if I said 1/3 plus 3 over 1, is that 1 also? No, that is not 1. So, if I have sine x over 1 times 1 over sine x, does that equal 1? This does not equal 1? It does, right? Because they're reciprocal. So what's sine? Sine times 1 is sine. 1 times sine is sine, so sine x over sine x is 1. But sine x over 1 plus 1 over sine x. Can I do that? No. Okay? No, I cannot do that when I add and subtract. But there's people doing that. Okay? All of a sudden we put words involved, and now we think that we can just cancel words all over the place. Can't do that. Okay? Words are the same as numbers. Okay? We cannot do this. So, the reason I say that, because this example, tangent squared x plus cotangent squared x. Yes, those are reciprocals, but we're adding them. Adding reciprocals is just adding reciprocals. There's no canceling we can do. So just like the first problem, tangent squared x plus cotangent squared x is nothing. The only thing that we would think about is a Pythagorean ID. And do tangent and cotangent go together? No. Tangent and secant go together. Cotangent and cosecant go together. But we can factor this a little bit more. Tangent x, cotangent x, cotangent x, one's plus, one's minus. And that's as far as you could go on that problem. So, factoring, we're just giving you some examples of factoring because that is a skill that you might need to do when you're simplifying and or doing a proof. All right, so this first example, when I look at this, cosecant b equals sine b plus cosine b cotangent b. So I look at that and I first have to pick a side. Remember, with a proof, you pick one side. The other side stays the same. You're not solving anything. You are simplifying one side until it gets to the other. So on your quiz yesterday, I could have given you just the right side and said simplify. And now, maybe your answer's right when you get down to a single term, maybe not. With a proof, you know what your answer is. All it is a simplifying problem, and you know the end result. So if you do a bunch of work and you get down to a single term and that term is secant, you know you've done something wrong because your answer should be cosecant. So remember, you can abbreviate the left side with LHS if you want, left-hand side. Since cosecant B isn't very much to write, I'm just going to write cosecant B every time. You must write it every single time. Yes, it's a lot of writing, but that's what a proof is, a lot of writing. And then when I look at the right side, the first thing I want to think of is there a GCF? Okay, sine, cosine, and cotangent. There is no GCF. If there is, I want to take it out, just because that's always usually something that will help me. But in this case, there's not one, so obviously I can't do that. So then my next thought, since there's not a GCF, I can change to sines and cosines. So sine B stays plus cosine B stays times cosine B over sine B. And then when I prove, I want to state my reason. So the reason that I used, why was I able to go from what was given to here? Well, that was called the ratio ID. There's no other possible reason for that other than ratio ID. Now, can I do this? I have a sign in the numerator and a sign in the denominator. No, because of its adding. Okay? Lots of people doing that still. You cannot do that. So, what I would do after grading your quizzes is make this one more step right here and make this sine B plus cosine squared B over sine B. This will help reduce a lot of mistakes. That one extra step right there. And what did I do? I multiplied. Combine is going to be for add and subtract. Do not substitute the word combine for multiply. What did you do? You multiplied. And now I would get a common denominator. All right, some of you could go from this first step to getting a common denominator. That's fine. But again, after grading that, if you didn't make such a good grade, that second step right there will be very helpful so that you don't mess up. Because if you mess up on the second step, the rest of the steps are all going to be wrong. So now what I would do is get a common denominator. So I would multiply this by sine B over sine B. So cosecant B equals, that's going to be sine squared B over sine B plus cosine squared B over sine B. And what did I do? I got an LCD. If you show that I multiplied by sine B over sine B, then multiply is okay. If you don't show it and you just do it, then you need to say LCD. But if you show what you did to get an LCD, then multiply is fine. But if you don't show it, you can't say multiply because there was nothing there to do. Then you have to say LCD because that's what you got. Now that I have an LCD, I can add my numerators. Now, some of you notice right away what that numerator is going to be, and that's fine. I'm going to show one extra step that's not necessary, but helpful for some people. So sine squared B plus cosine squared B over sine B. And all I did right there was combine. You can say add. And now what does that numerator equal? 1. So we have cosecant B equals 1 over sine B. This step is necessary. This one right here, that combined step, didn't have to have it. This step right here you did, and that was because of the Pythagorean ID. And I'm fine if you abbreviate as long as I know what your abbreviation could stand for. Don't say RID, because there's a ratio and reciprocal. Okay, you've got to have some kind of the letters. And then we use our reciprocal ID. Cosecant B equals cosecant B. And again, that was because of the reciprocal ID. Notice the left side never changed. I cannot do something to both sides. I pick one side, and all it is a simplify problem. Simplify that side. The proof just states your reasons. And again, with the proof, we know what our answer should be. So if we get down to a single term and we don't have the other side, then we did something wrong along the way. We know we messed up somewhere. Question? If you are like reducing, so like if you had sine times sine over sine, like sine squared over sine. And then you cancel, so cancel, simplify, reduce, those three are all interchangeable. Other questions? All right, so this last one, first I added a little bit to it. So if I were to ask you to factor 1 minus 3x minus 4x squared, okay, that is a factor problem you've been doing since Algebra 1. So we do our two parentheses. We split up the first term, 1 and 1, and then we split up the last term. So we have two choices, 2 and 2 or 4 and 1. The middle number doesn't have anything to do with the numbers we write down. It has to do with what numbers we choose. So with 4 and 1 or 2 and 2, 2 and 2 can't get us a 3, but 4x and 1x can. Okay, so we split up the first term, we split up the last term, and then we put the correct signs. We need a minus 3x. So minus 4 plus x. Okay, a simple factoring problem. Now, that's sometimes a little backwards. You normally like to see it the other way, which is possible. Okay, it could be written the other way. Negative 4x squared minus 3x plus 1. It's possible to factor that also. We would split the 1, the 4x and 3x, so it would be 4x and x. But the 4 is negative, so then we just have to make that a negative, and we have the exact same thing, just in a different order. With these proofs, we do not want to change the order. Okay, I will tell you, you can, but that just adds anywhere from 2 to 3 steps to your process. So you don't want to change the order. Just leave it in the order that it's in. Now, I picked these numbers because look at this problem. 1 minus 3 cosine, so I replaced the cosine x with an x, or the cosine a with an x. Minus 4, I replace the cosine squared a with an x squared. It is the exact same problem. So when you see a problem like this that's a trinomial, it's just a factoring problem. But the key to these problems is to look at this word right here. This word right here is the important word. All words in the problem must match. That is how you decide what word. And by word, I'm talking about sine, cosine, secant, cosecant, tangent, cotangent, whatever it is. You look at that word. So all the words in the problem. So we're looking at the left side. So here's a word, word, and word. So there's 3 words. All of those words have to be cosine. Sometimes they are, sometimes they aren't. If they aren't, okay, for instance, if this said sine squared, do we have an identity that allows us to change sine squared to cosine squared? Yes, our Pythagorean identity. So if the word doesn't match, we use our Pythagorean ID to replace, substitute, plug in, combine like terms, and solve the problem for there. This side over here is kind of helpful because really it kind of gives us some of the factors. We're going to factor this, and it gives us 2 of the factors, one of the factors in the numerator and one in the denominator. So really you don't have very much work to do because the factors are already given. Now, before I do anything, I need all three of these words to match. So the numerator is good. 1 minus 3 cosine A minus 4 cosine squared A. I need sine squared A to change its work. Now, I can't just change it to cosine squared A. That's not a thing. But I can use my Pythagorean ID to make it 1 minus cosine squared A. That is a thing that we can do. And that's a lot to write every time, so I'm going to start out with just right-hand side. And what did I do? I used my Pythagorean ID. Typically, when you do a proof, you want to do one thing at a time. Okay? By one thing, I mean one operation. So one reason at a time. But you could do something in the numerator and something in the denominator on the same step if you want. Like we could have factored and changed this at the same time and had two things. If these proofs are confusing to you, just do one thing at a time and it'll be a lot more helpful. But if you can do more than one, as long as one thing in the numerator and one thing in the denominator, that's okay. Yes. If you do two things at once, you have to write two reasons. So if you had chosen to factor the numerator and change the denominator, you would have said factor over here and then Pythagorean ID. So if you're going to do two things that are not the same, like if you factor the numerator and denominator, you don't have to write factor twice. But you have to say everything that you do. All right, so everybody good with what I did so far? Okay, so now all the words match. That's my first goal. Make sure the words match. You can't do anything until the words match. And with a problem like this, you never want to change the sines and cosines where it might not be incorrect. It's not going to do you any good. It's going to give you some ginormous problem that is impossible to figure out. You leave it with whatever word is there. Now, this right here, I can factor both of these. This is just a trinomial, and this is a difference of two squares. So just like I factored that problem a second ago with the x's, I'm going to split up the 1. I need to split up the 4 cosine squared A into either 4 times 1 or 2 times 2. 2 times 2 won't get me a negative 3, but 4 times 1 will. So 4 cosine A, 1 cosine A, or just cosine A. Since I need a negative 3 cosine A, this is negative and positive. If I were to FOIL those back together, 1 times 1 is 1, negative 4 cosine A plus 1 cosine A is negative 3 cosine A, negative 4 cosine A times positive 1 cosine A is negative 4 cosine squared A. And then the bottom, we've been doing that for at least 2 or 3 days, 1 and 1, cosine A is the difference of two squares, one's plus, one's minus, equals right-hand side. And I did something on the numerator and the denominator, but it was all the same, so I can just say factor. And now, I have 1 plus cosine A on top and on bottom. And so now I have my answer. 1 minus 4 cosine A over 1 minus cosine A does not equal the right-hand side. It equals 1 minus 4 cosine A over 1 minus cosine A. And there I can say simplify. You can say reduce. You can say cancel. Any of those, whichever word's your favorite. Okay, you don't have to say them all. Any of those words will work.